Hello everyone, welcome back to part 2 of the chapter 1 notes. We're going to start here on, what is this, page 3? Page 4. Okay, so we'll start here on page 4. If you're looking for the first 3 pages, they are in a different video. Okay, so now we're going to go over inverses of functions. Okay, so we can read over this super quick, and then you can, if you need, you can pause and reread it. To find the inverse of a function, we want to switch those x and y variables in the function in itself. It says, given that f and g are inverse functions, if f of a equals b and g of b equals a, in other words, each ordered pair, if you say have an ordered pair 1, 2, its inverse would be the switch of that, 2, 1, okay? Another one here is if it's reflected over the y equals x line, which is just that diagonal line from bottom left to top right, slope of 1, y-intercept of 0. And then the last part here is if the compositions of the functions, f of g and g of f of x, they both come out to equal x, okay? The fact that they come out to equal x and not necessarily like both equal 3 or both equal the same number, it has to come out to be x. Okay, is a function, if a function is 1-to-1, then it passes the vertical line test and the horizontal line test. Okay, so this means that the function itself is a function, but also the inverse is also a function. Okay. For each input, there's exactly one output, and for each output, there's exactly one, okay? So here, it tells us that it's a 1-to-1 function, so we already know that. But in order to find it, I'm going to do that first one that we talked about where this, remember, is just a fancy output for y. So what I'm going to do is I'm going to switch that to an x, okay? No real math functions behind this, just literally switching x and y. Okay, once I've switched it, now I want to solve for y. So in this case, y is stuck in the bottom, so I'm going to multiply both sides by 7y minus 8. Cool. And so I have x times 7y minus 8 is equal to 5. Now I don't want to distribute in the x because I'm trying to get the y by itself, so I'm going to just divide by x. And so then I'll bring it right over here. 7y minus 8 is equal to 5 over x. And now just keep solving it out. Whoa, that's a crazy x. That's an x. Add the 8. So 7y is equal to 5 over x plus 8. And then divide everyone by 7. And so y is equal to 5 over 7x, right? This is 7 over 1. You can skip, flip, and multiply in order to get 5 over 7x. And then this is 8/7. This is totally fine, or if you want to get common denominators, right? So common denominators, we would want to multiply top and bottom by x here. And so I would end up with 5 plus 8x all over 7x. And so that one is fine, and this is fine. Cool. So that's how you find the inverse. Now, typically what you'll see is this says g of x, but what we'll normally see is like this little to the -1. You could see something like this as well. All that tells me is, hey, look at me, I'm the inverse. Okay. So again, no real like math operations to get there. Excuse me. But it just shows, it's a title that shows that it's the inverse. Okay. Now here on this one, it says use the graph of f of x as shown on the right to draw the inverse function. So this is the one that we're going to use different coordinates. Okay, so we'll say f of x, and so we'll find a few nice coordinates. So here's a good one. So this is going to be at -5, 0. And let's find at least one more. If you see right here, that one's nice. It crosses the x and y really cleanly. So that's -4, +1. So now in order to find the inverse, you're going to literally just switch. I'll call it g of x, but you're just going to switch the x and y coordinates. So now I have 0, -5, and 1, -4. Plot those guys. So 0, -5, 1, -4. And it would look something like that. Okay. If you did a quick look on the graph, remember one of the other ones that we could say is here's the y equals x line, and that should reflect over there, and it does. Okay, my graph is not amazing, but I would guess they would meet up right here if my graph was a little bit better, but they should reflect over that green line there. Cool. Nice. Now number 16 is saying, are any of these guys inverses of each other? Well, what we're going to do for these, for some reason this one gets a lot of, you guys have a little bit of trouble with these because not totally understanding with it. But with these, all we're going to do is find the inverse of one of them, and that's its inverse, right? And then we'll compare it to the other ones and see if, well, does that actually match what the inverse is, right? So this one will switch, x is equal to 3y, and then we'll solve for y. So divide by 3. So y is equal to x over 3. That is the inverse of f of x, right? And so it says, are these guys inverses of each other? Well, we just found the inverse of f of x, which is this guy. Well, do any of these either of these two match it? And the answer is yes. This guy matches it exactly, right? Those are the same. So what we would say is we would say f of x and g of x are inverses. Okay, so they're inverses of each other because initially I found out what the inverse of f was and compared it to the other g and h of x functions. Cool. Nice. Now transformations of a function. Hopefully you remember this from your Algebra 1 and Algebra 2 days, but this is moving, stretching, compressing vertically, reflecting it vertically, moving it left and right, up and down, all that kind of stuff. Okay, so I'll let you read through this. This is all of our individual transformations with A. A's got a few different ones. H does a shift left and right, and a vertical shift up and down. Here's all of the parent functions. Okay, so we should be pretty aware with these. Definitely in the top, top 3, definitely. And then the next 4, maybe refresh yourself on these parent functions. Okay. So it says here, sketch each parent function and use the transformations. Okay. So the parent function here, so for y is equal to absolute value of x, that's where our vertex was at 0, 0, and it's got a slope, because there's a 1 outside here, a slope of 1. Okay. Since it's absolute value, it's reflected over that axis of symmetry, and so that is y. Now if I use my transformations, okay, it's the same parent function there in the green, but now because of this, it tells me I'm going to move everything up 1, and this one here, it's going to stretch it, so a vertical stretch. Okay. So now I take my vertex, I move it up 1. So that's going to be that. And now instead of a slope of 1, my slope is going to be 4. So up 4 over 1 and reflect that over. So that right there would be g of x. So transformations there, we stretched it vertically and we also vertically shifted it up 1. Nice. So same thing on this one, we'll do this in pink. So that is the cube root. So if you look right above, the cube root kind of looks like an S. So the best way I describe it is get your h and k, which would be at the end here. We don't have one, so it's 0, 0. And then it's not a slope because it's not a straight line anymore. But if you notice, if you go to the right one, it'll always be up or down your a value. In this case, our a value is 1, so we go up 1, and then it's reflected over the center. Okay, so over the center, so this is the other one. I always tell my students that have a hard time drawing this is I'll always kind of draw a straight line here, and then flatten out both ends. So there's my parent function right there. Now if I do my transformed one, this guy right here is going to tell me that it's reflected. And this one right here, since it's the h, we always do the opposite of h, so it's going to move it over to the left 5. Okay, so we'll take this initial point here. Okay, our center point, we'll move it over 5. And now instead of going to the right one and up 1 like we did for the pink graph, we're going to go down because it's reflected. But you still do the same process, reflect it over the center. I like to draw my little straight line and then flatten it out. And that would be g of x. And so just a couple of reminders of your transformations there. Now this one looks a little bit different, but the nice thing is your graph is already given. You just got to know what each one of these does, okay? And so if you recognize on this first one, we've got -2 f of x, right? So the -2 is out in front, which that would be our a value, right? And so that's going to adjust the vertical part. That's the vertical stretch or compress. So what I would recommend is it's only changing the vertical. So let's set up our equation, x, y. So this first point's at -6, the second point's at -4, what's that, -1 and 6. Cool. Now our y's, we can keep the y's, so -4, 2, 1, and 6. But again, the y is being adjusted. Sorry, that's a really bad 4. Is being adjusted, and so it's being stretched. So a stretch and compress is a multiplication. So I'm going to multiply each of these guys by -2. If it was like a horizontal shift, I would be adding or subtracting. So if I do that, this is +8, this is -4, -2, and -12. And now what I'm going to do is I'm just going to plot these new coordinate points. Okay, so at -6, 8, let's see if I can do it, -4, -4, -1, -2, and then 6, -12, way down there. Okay, and then just kind of connect the dots. So this one comes down, up, and then back down. So that is with a reflection and a stretch of 2. Now same idea over here. So if you notice, we've got a reflection, and then here, this is outside of the parentheses. So that is your k value, right? So that's going to move it up and down. So that moves it up and down. So again, nothing is, my x is not getting adjusted here. So I'm going to pick this point. I'll pick the kind of the vertex there, and then that point there. So we've got what, -4, 4, 0, 0, and 4, 4. Now a couple things is I'm going to multiply it by -1. That reflects it. And then I'm going to subtract 1 because that brings it down vertically. So that would be what, -4 minus 1, so -5. 0 times -1 would be 0 minus 1, so -1. This would mean -4 and -5 again. Okay, so replot this, -4, -5. So we reflected it and shifted it down 1. Like that and like that. Hopefully I got those points correct. And something like that. Cool. Okay, our last little section here is, again, maybe refer back to what is a function in the first video if you need. So it needs to have a unique output for every input. So you're going to look through and look for big things. So here, if you notice, the x is repeated. And so therefore, one input has multiple outputs. So this is a no. Okay, so not a function. Again, the reason is we should have a unique output for every input. be careful on these, because sometimes if you'll see in a list, they'll do a list, blah, 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 do a bunch, and then they'll do -3, 2. You might think, okay, I see 2 inputs. Nope, can't be true. But here, they have the same outputs. So in that case, that would be a function. Now, the next few is, or next 2, I guess you have to be able to picture what the graph looks like. Right, this would be a circle with a radius of 5. So we've got a circle here. Unfortunately, does not pass our vertical line test, so we'd say no, not a function. Now this one is, I call it half a C, right? So it looks kind of like this. So if you can picture the graph, it looks like the bottom half of a C. If I did my vertical line test, totally good to go, right? Only hits it one time every vertical line. So we would say, yes, this is a function. 24 and 25, those are really nice because the picture is given to you. So 24, again, is a yes, because it doesn't matter how many vertical lines I draw, it never hits the graph twice. And then 25, pretty straightforward, hits both right there and right there. And so this one's a big fat no, okay, unfortunately. Well, I hope you enjoyed it. Please tell a friend.